In this video, we talk about the Internet Protocol address. So what is an IP address? IP stands for Internet Protocol. An IP address is like a digital home address for your devices on a network. It's what allows devices to locate and communicate with each other. Each device in a network is identified with a designated IP address and MAC address, which is used to locate and communicate with other computers in and outside the network. John bought a computer and connected it to his home router. The router gives the computer an identification to use and communicate with other devices connected to the home network. An IP address is a set of 4 numbers separated by dots, such as 192.168.2.1. Each set is called an octet and can range from 0 to 255. There are 2 versions of IP addresses: the Internet Protocol version 4 address and the Internet Protocol version 6 address. The IPv4 address is a 32-bit address with 4 octets separated by dots. It can provide up to 4.3 billion unique addresses, but it is small in quantity, which causes its depletion. With IPv4, John connects his laptops, printer, and other IoT devices, giving static and dynamic addresses when necessary. But as time goes by, higher hardware that used static addresses starts experiencing latency and network congestion. John worried that his business might collapse at this rate, researched for more ways to stop this, and came across the IPv6 address. The IPv6 address is a 128-bit address with 8 hextets separated by colons. With this, it could provide up to 340 undecillion unique addresses. This reduces the problem of depletion since it has a lot more addresses than the IPv4. With this, John could solve his latency issue and network congestion. John changed his printer, television, Xbox, and other IoT to a static IPv6 address, increasing the end-to-end connectivity. Now the question lies, how does John communicate with devices with IPv6 addresses using his computer that still operates on IPv4? Well, with dual stacking, John's computer could also have an IPv6 and IPv4 address coexisting. Also, other methods include tunneling, which encapsulates an IPv6 address over an IPv4 address. Encapsulation is the act of wrapping packets of higher protocols within one with a lower layer protocol. Just take it as writing a letter and then encapsulating it in an envelope and writing both the source and destination address. That's how it works. The last part is a translation. NAT6 enables IPv6 addresses to communicate with IPv4. Now there are 2 main types of IP address: the private and the public. The private. John's home laptop was connected to the home router, and the dynamic host control protocol gave him an IP address. This IP address is changed anytime his computer connects to the router. Now this IP address is usually ranged within these classes. Class A, these support large networks. Class B, these supports moderate to large size networks. Class C, these support small networks like John's home network. John also bought a printer to print out his files from the computer, but this time he doesn't want the printer IP address to be changed every time he connects it. So he inputted a static IP address to his printer. With this, it doesn't change dynamically like his computer. So the characteristics of the private IP address include: it can be static and dynamic. The private network, as the name suggests, cannot be used to browse the internet. It can only be used to communicate with devices that are connected to it. Now John wants to access the internet. How does he do this? He reconnects the laptop to the router and is assigned a private address. He then opens up his browser and inputs a URL. Now his router, using the network address translation, he converts his private address to a public address, making it possible to communicate with devices outside the home network. These public address ranges from: public addresses are assigned by the Internet Assigned Numbers Authority and then managed by the regional internet registries. There are also some special types of IP addresses. The loopback address is used when a host tries to direct traffic to itself, pinging himself. The link local address, this is usually used by a host to reconfigure itself in the event he or she can't obtain an IP address. The multicast address this is used when a host wants to send packets or data to a set of designated hosts. Unicast this is used to send packets to a single registered user, where both the source and destination IP are unicast. With these, John now understands how IP addressing works and continues to develop his business. For any question or video request, ask in the comment section. This is Chubby Tech, and I will upload more videos for networking, so follow for more.